See what's in this side of the cave. And cavers must have been hungry because there are a lot of formations named after food. There's things like cave bacon and cave popcorn.
Welcome back to the Bureau of Economic Geology's Austin Earth Science Zoomerama. Today's speaker is Jessica Gordon from the City of Austin's Watershed Protection Department. Jessica is going to be leading us on a very cool virtual reality tour and talking to us about surface water, groundwater interactions, and cave protection. Thank you, Jessica.
Sure, thank you. And Linda also often likes to ask how we got into this field. So yes. I wanted to share that it all began when I was a graduate student at the University of Texas at Austin in geography and the environment. And I became involved in a program with the Environmental Science Institute that connects graduate students with K through 12 teachers. And it was also focused, we got to take lots of field trips to caves and springs to learn about the hydrogeology of the Edwards Aquifer. And I have been hooked ever since. I got swept away. I realized my passion was for outdoor environmental education. So I continued to pursue a second graduate degree in education focused on outdoors. And I now get to, as part of my job, take kids to creeks and caves and springs. So I really love what I do. And today, let's see if I can go ahead and share my screen. Can everybody see that fine?
Yes, looking good.
Excellent. So today, like Linda mentioned, we'll go on a virtual cave tour while we learn about surface groundwater interactions and other environmental science issues that affect our community, like flood safety. So I'll go over a little bit about watersheds and aquifers. A watershed is an area of land that drains to a creek, lake, or river, and an aquifer is an underground layer of rock that holds water. And we'll talk about the hydrogeology of the Edwards Aquifer, meaning how water travels underground from the surface underground and then to springs. And then we'll go on a virtual reality cave tour, and then we'll talk about Flash Flood Alley, why Central Texas has major flooding issues and what you can do to be safe. So this is one of our maps. All of these different colors are watersheds in Austin. And this blue squiggly line is the Colorado River. And then this kind of white waffle print area is the recharge zone of the Edwards Aquifer. So these are some of the things that we're going to be talking about today. And later we'll get to look at a map that shows you where you can discover which watershed you live in and whether or not you're in the recharge zone. So first we're going to watch a short video. Let me click on the link.
Hello, I'm Jessica Gordon with the City of Austin Watershed Protection Department. Today, we're going to see how different kinds of ground cover affect how much water runs off the surface or soaks into the ground. Let's start with this concrete. This concrete represents a hard surface, like a driveway or a parking lot. What kind of pollution might we find on that kind of surface? We're going to use red food coloring to represent oil and other pollutants that might be on driveways or parking lots. Now we're going to rain on the model. The water that's coming out of this top spout represents water that runs off the surface and goes to our creeks or river. The water in the bottom spout represents how much water soaks down into the ground. As you can see, almost all of the water has run off the surface. This can lead to flooding problems. Now we're going to look at the soil. This could represent a construction site or an area of bare land. So what kind of pollution could be on a construction site? We're going to use the red food coloring again to represent motor oil and litter and other things that could be on the site. Now let's rain on the model to see what happens. As you can see, most of the water ran off the surface. This can vary depending on what kind of soil you have, but ours is very rich in clay, so only a little of it was able to soak in. We also had a lot of erosion. And this model represents a lawn with turf grass. We're going to add food coloring to show different kinds of chemicals that people might put in their yards, such as herbicide to kill the weeds, or fertilizer to help the plant grow, or pesticides to kill the bugs. Now let's rain on the models. You'll notice it has some runoff, but it's slower than the other runoff. And now some of the water that is soaked in is starting to come out of the bottom spout. As you can see, a lot of the water did soak into the ground, but we also still had some runoff, and all of that pollution that was on the land ended up in the water. The last model we're going to talk about today is a rain garden. We have a rain collection cistern, rocks, and native and well-adapted plants that don't need chemicals, so we're not going to add any pollution to this model. It's time to rain. As you can see, we hardly had any runoff. Rain gardens are great at absorbing the water and helping it filter slowly through the plants and the roots, taking out any pollutants. We didn't add any pollutants to this model, but if we had, the water would still be cleaner than the others. We also have the rain cistern here that has collected water. As our results show, the turf grass, soil, and concrete had the most runoff, which can have a negative impact on flooding, erosion, and water pollution. As our results show, the rain garden absorbed and filtered the most water, which helps reduce flooding, erosion, and water pollution in the area. Rain gardens can also be an effective way to solve drainage problems on some properties. If you'd like more information about how to run this activity or how to build these models, check out the link in the description below. Thanks for all that you do to help protect water in your community.
All right. Now let's get back to the presentation here. And we were on. Okay. So now we're going to take a journey back in time about 75 to 100 million years ago. This is what Central Texas looked like at that time. So there were dinosaurs and beaches right here in Austin. So there were some points of time, this is all during the Cretaceous period, where a shallow seaway went up the whole middle of the United States and Texas was entirely underwater. And there were other times that what we also now call the Balcones Escarpment, or the Balcones Fault Zone, right in this area was the coastal line. And Austin is right at the edge of it. So it was like we were right at the edge of the beach at that time. And we know this because fossils provide evidence. So here's a plesiosaur and a volcano erupting in the distance, a mosasaur, an ammonite, and clams. So these fossils provide evidence, and you can see all of these fossils at the UT Texas Memorial Museum. Now, water can combine with carbon dioxide and make carbonic acid, and that slightly acidic water can dissolve holes in the limestone. And in the Edwards limestone in particular, it creates these honeycomb-like passages that provide pathways for water to travel through the ground. It also creates cave formations. So as the water is going through the ground, if it dissolves a really big hole, if it's big enough for a person to enter, then we call that a cave. And as the waters dissolved the limestone, also known as calcium carbonate, then when the drop of water gets on a cave ceiling, like right here, some of that water can evaporate and it can leave behind or deposit some of the limestone, making formations such as stalactites hang tightly to the ceiling, stalagmites growing up from the ground. You have to be careful because you might trip on them. And when they grow together, they're called columns. This is another graphic that shows some features of the recharge zone. So we have features like sinkholes, which I'll show you a picture of in a moment. We have caves. We have faults, big cracks in the ground, and fractures, other cracks in the ground. And then the water travels underground. Here's the water table. This is the space where above the water table, there's air in the openings in the rock. And below the water table, there's water in the openings. And then when a water comes back out of the ground, we call that discharge or a spring. So as you can see, the Edwards Aquifer covers a pretty good portion of Texas. It goes north of Austin up to the Temple area and west of Austin near Del Rio, But the main portion I'm going to talk about today is called the Barton Springs segment. So it has the northern segment above it and the huge San Antonio segment below it and to the west. But just this little part, as you can see, it's in Travis and Hayes County, and it's in the South Austin, is the Barton Springs segment. So this is a closer view of the Barton Springs segment, and there are 3 different zones. So there's over here to the west in green is what's called the contributing zone. So in this area, the water is on the surface, and these are the main watersheds or creeks that flow over the recharge zone, which is shown in orange. So as water's flowing on the surface, it goes into these creeks, and then it goes into the recharge zone. And when it gets into the recharge zone, it goes down into the aquifer. And then in yellow, we have what's called the confined zone or the artesian zone. And that's where there's water underground in the aquifer, but it is covered by an impermeable layer that water can't travel through. So water can no longer enter the aquifer in that zone. I'll show you another graphic that will help us see this. So this is a cross-sectional view of that same thing. So about 13 to 20 million years ago, there were lots of earthquakes in our area, and it caused faulting, and it caused west of Austin to go up relative to the east to go down. So this right here, this holy layer is the Edwards limestone. Although it was deposited flat because of the earthquakes, you can see here it kind of has like a staircase. And that's what Balcones escarpment gets its name from, is that staircase pattern. So in the contributing zone, that holy rock, the Edwards limestone, is at the surface. And then you can see water flowing at the surface. And then you can see that in the recharge zone, it starts to stair step downward. And so that's the main place where water enters the aquifer is in that recharge zone. And then here in the confined zone, there's an impermeable layer that water can't go through up above it. And so the water is down underground in that part. So here's an example of a sinkhole, place where water can enter a big hole directly and go underground. This is a nice thing that shows you what we call that honeycomb limestone. We also call it karst, limestone that has lots of holes in it. And those holes are so big that they're not a good filter for pollution. So any contaminants, any pollution that's on the ground can get into the water and flow directly into those holes. And here's a recharge creek. The water's disappearing right here. So there's a special feature called recharge creeks or disappearing streams. In the recharge zone, there's water at the surface, but then it quickly goes down underground. It disappears into a sinkhole. But as you can see, there's a tire and other pollution into the creek. So that's pollution going into our aquifer. Here's an example, fortunately, of some cleaner water. This is an Onion Creek. And when there's a lot of water in the creek, it creates a whirlpool as the water gets sucked down and goes down into the aquifer. So hydrogeologists, who are scientists that study how water travels underground, have done what they call dye trace studies, or they trace the groundwater by adding a non-toxic dye. So sometimes the dye looks kind of scary because it's often neon colors, but it's not toxic, it's not harmful to living things. They just want to use it to trace where the water goes and how long it takes to get there. So I'll give you one example. This right here is Midnight Cave, which I'll show you a picture of later. It's a beautiful 50-foot waterfall underground in Southwest Austin. I bet you didn't know Austin had a 50-foot waterfall. It's a pretty cool place. So the water travels from there, and you can see it goes 8.3 miles. It goes this way, and then it goes that way, and it comes out at Barton Springs. And it does that in just 7 to 8 days. So that's traveling more than a mile a day. For water traveling underground, that's extremely fast. For example, in a sand aquifer, it can take more than a year or even more than 7 years for water to travel 1 mile. So a mile a day is very quick. But because of that, that also means our aquifer is not good at filtering out pollution. So in a sand aquifer, water moves very slowly through tiny holes, and that can help filter pollution. But in our karst aquifer with really big holes, water moves quickly and pollution does not get filtered out. So in order to have clean water in our springs, like Barton Springs, we need to take care of the land in the contributing zone and in the recharge zone to protect that water. So I mentioned the water comes out at Barton Springs. And if you've been swimming there before, how did the water feel? Cold and refreshing. I'll show you a couple of places where it comes out. If you go into the main entrance of the pool and look across where the diving board is, and then look to the right, you'll see a lifeguard stand. And to the right of that, there's a big crack. That's a big fault. And this is one of the places water comes out of the ground. There are also some other little springs in this area. If you look around for them, you can feel the pressure of the water coming out of ground. And then also where there's the ledge that goes from the shallow end to super deep, there's an underwater cave that water comes out of too. An endangered animal lives at Barton Springs, actually two, the Barton Springs salamander and the Austin blind salamander. These salamanders are endemic to Austin. They only live in the springs of the Barton Springs segment of the Edwards Aquifer and its contributing zone. And they're very sensitive to pollution. So they serve as good water quality indicators. So protecting the water quality to be good enough for them to be able to survive in also helps protect the water quality for other wildlife and for humans to enjoy recreation. How can education make a difference? I mentioned that 50-foot waterfall underground. This is in Midnight Cave. Unfortunately, a long time ago, a lot of ranchers would fill caves and sinkholes with trash. This is for a couple of reasons. One, they didn't have trash pickup like we do. So out of sight, out of mind, they could just put it underground. Also, they didn't want their animals getting stuck in these holes, and so they would fill these holes with trash. Later, people realized the connection that this was actually polluting the water to have all of this awful trash and contaminants in there. And so they worked to clean this out, and they literally removed tons and tons and tons of trash. And now it has beautiful crystal clear water inside. So now we're going to watch a short video that kind of covers some of the topics that I just discussed.
Hydrogeology starts with the combined fields of geology and hydrology, studying the flow of water through the soil and rocks below the Earth's surface. Most vital to Austin and the surrounding areas is the Barton Springs segment of the Edwards Aquifer. It provides drinking water for 50,000 people in neighboring Buda, Kyle, and Sunset Valley.
Wherever these creeks cross the fractures and the faults, then we have the potential for creek flow to be entering into the aquifer.
Where does the water in the Barton Springs segment of the aquifer and in Barton Springs itself, where does that come from? Well, we know that it enters through the area we call the recharge zone, but the source of the water can be a lot farther away from that. There's an area that we call the contributing zone. It's not actually part of the Edwards Aquifer, but it's part of the surface watershed that contributes water to the aquifer and to Barton Springs. What I mean by that is there's a large area and water that falls as rainfall on that area flows into creeks. There are 5 principal creeks that flow across the contributing zone that contribute water to the Barton Springs segment of the Edwards Aquifer. Those are Barton Creek, Williamson Creek, Slaughter Creek, Bear Creek, and Onion Creek. And of those 5, Onion Creek and Barton Creek are the largest contributors to the aquifer.
During heavy rainfall, a whirlpool forms in Onion Creek.
Whirlpools are very fascinating natural features. The sound is awesome of a whirlpool. The whirl of the water is mesmerizing. Well, one gentleman went out to try to touch the whirlpool, and the force of the whirlpool, the natural force behind it, is so powerful that it sucked him into the whirlpool, and he died instantly, unfortunately. What we can see from measuring flow along the creeks here is that there's really only a handful of places on the creek where most of the water goes underground into features like this. Even though we're here on the bottom of a creek, this is Onion Creek, right now it's dry and it doesn't look very outstanding, but this creek is actually the largest source of water to Barton Springs. It produces about 40% of the water to Barton Springs. When the water is flowing, obviously it's not right now.
There are three very distinct segments. The northern Edwards begins just north of downtown Austin and travels north to Temple. Then the southern segment travels south from Hays County. The southern Edwards supplies San Antonio's drinking water. Known locally as the soul of Austin, Barton Springs is the city's most prized jewel. It's named after frontiersman Billy Barton. In 1837, Barton claimed this area when the United States was giving away land to encourage settlement of the new Republic of Texas.
Barton Springs itself is really made up of 4 separate but related springs. Upstream of the pool is Upper Barton Springs, but the main springs that we think of behind me is called Main Barton Springs, or also Parthenia, named after Billy Barton's daughter.
When you jump off the diving board, just look to the left and you will see her. She's by far the largest of the 4 springs, producing an average of 53 cubic feet of water per second, which is enough to fill a 2-story home per second. Both Eliza Spring and Sunken Gardens are east of the pool. Even thousands of years ago, before Billy Barton, Native Americans could drink from the spring because it was crisp, cool, and naturally clean. Thanks to a new technique called dye tracing, a lot has been discovered about the aquifer over the last 15 years. Dye tracing helps track the water as it flows underground through different discharge points.
We have some receptors, or what we call bugs, that we put in these wells that will absorb the tracers that we're using. That's activated charcoal, so that's what will absorb the dye, so that we can determine whether the tracer is moving from our injection point to this well and points beyond.
Through this dye tracing test, scientists have learned most of the water entering recharge features in the Barton Springs recharge zone releases at Barton Springs. Remaining water surfaces at Cold Spring, which is located in Lady Bird Lake. Once the water surfaces, it travels downstream and then into the Colorado River. From there, it travels to the Gulf of Mexico, helping to provide water to our neighbors downstream.
So let's learn a little bit more about what it's like to be in a cave, the aquifer. So this is Millennium Cave. I heard one of the students ask which cave was as my background, my virtual background, and that's this cave that we're about to go explore. This is Millennium Cave. It's in Southwest Austin, kind of near Mopac and Davis Lane. And if we look around, we can see that it's in a neighborhood. It's in a park that's in a neighborhood. So there's a house right over there. And you can see there's some trees and some tall grass. Here are a couple of my friends and coworkers about to enter the cave with me. So this is Marvin and Trent. And then we'll turn back around to see the cave. They discovered the cave when they were drilling a hole when they were building this water quality pond to be able to treat and clean out the water that was coming from the neighborhood, the runoff from the neighborhood. So you can also, this is on a website, and the link is shared with you on the event page. And we actually have 2 virtual cave tours. There's also another one you can go into called Wildflower Cave. And you can use virtual reality headsets if you have them, or you can also get them pretty inexpensively, even cardboard ones that you can make and you can use with a phone. Or you can just tour like I am right now on the computer. You'll notice there are these little arrows. So you can tell I'm about to go into the hole, and if we push on the arrow, it takes us down inside the cave. And then you can move the arrows to look around and explore. And this is an incredibly beautiful cave in Austin. And it has these large cave formations. Let me show you. Okay, here's the ladder that I just came down on. So we'll look up at that ladder. Gives you an idea of how big this cave room is. And then check out these formations. Look how big these stalagmites are. Way taller than a human. And it has them all over. This is a really beautifully decorated cave room. And then if we want to go deeper inside the cave, we can follow these arrows to go further in. And we can look around some more, get a different perspective, look back to see where we just were. There's somebody now on the ladder from a different perspective. And then if we want to go a little deeper into the cave, let's go back over here. Find a nice arrow to go further into the cave. I really like this formations right here. It kind of reminds me of a tree because it looks like a big tree trunk and then it has a large canopy with lots of formations. We can go closer over there, see what's in this side of the cave. And cavers must have been hungry because there are a lot of formations named after food. There's things like cave bacon and cave popcorn. So you can travel through and go this way, go that way. We did this way. And there's a thermometer. Most of our caves are roughly the average temperature. So they're usually about 70 degrees Fahrenheit, which is the same for Barton Springs because that water is coming from underground. It's about 70 degrees year round. So the other thing I'm going to share with you is our Watershed Detectives webpage. Let's see, I think it's right here that is in my way. Okay, so here's our Watershed Detectives page, and we have lots of different activities. One I mentioned we're going to talk about today is called Flash Flood Alley and the Power of Water. And this is an interactive PDF, so it's kind of nice. Students can do this activity without having to print it. They can fill in these slots. And there are links to videos. This is a model of a low water crossing, and it shows you when you rain on the model, it washes the car off the road, and there's a little video that goes along with that. And then, as I mentioned, there's information about why Central Texas is called Flash Flood Alley. And then you also get to go to an interactive web map, like I mentioned. So let's check out what that web map is. So just like that picture I showed earlier with watersheds all over Austin, the blue squiggly line is the Colorado River. And you can click on a legend so you can see what information there is about it. And you can also change the legend if you want. So I can go right here to the layers and I can say, so all of these other colorful dots are different schools in Austin. And here's the recharge zone that I mentioned before. And so you can put in an address. I'll put in our office is located at 505 Barton Springs Road. And then it zooms right into my area. So I can see that my office is in the East Bolden Creek watershed. So I can see that we're not in the recharge zone to the Edwards Aquifer. And I can see the floodplain of East Bolden Creek. Now, if I want to be able to move around, I can just go where I want. I want to go check out Barton Springs, since that's been something else we were talking about today. I'm going to zoom out a little bit. Here's Lady Bird Lake. And then I see Barton Springs is right over here. So I will zoom into that area. But it's kind of hard for me to see the pool because the parks layer is showing all green to show me where parks are. And that's great if I'm studying parks. But if I want to see the aerial photograph, I can click off the parks layer, or I can make it transparent. So the watershed layer now is in my way as well. So what I can do is I can go to watershed boundaries and I can click on it and I can adjust different things about it. So if I scroll down, I can set visibility range and I can make it where it's completely, adjusting the wrong thing, sorry about that. Transparency. Okay, so transparency, I can make it where it's completely opaque if I just want to focus on studying the watersheds, or I can make it completely transparent if I want to see what's underneath the watershed like I do right now. And all of these blue dots are springs in the area. So you can tell that there are a lot of springs. And here's the boundary of the recharge zone. So all of this on the left is at the recharge zone. And this is Parthenia Spring. The spring at Barton Springs that we were talking about. And you can see it's right on the edge of the recharge zone to the confined zone. So here's the main pool, Barton Springs pool, and then you can tell that it flows into Barton Creek. And then if we scroll over a little bit more, it goes to Lady Bird Lake. So that's something you can spend time exploring later. And I'll go ahead and stop sharing at this time and see if there are any questions.
How long would it have taken to form stalagmites in the cave?
Excellent question. It can take millions of years or thousands of years. Some people say, so it depends on what the water flow is like, but just to give you a comparative idea, you can think about how long it takes for your fingernails to grow. It's sort of like that. So imagine, so even a short stalactite can take thousands of years. And then imagine those huge ones we saw in Millennium Cave. They took a very long time to form. But there are scientists that study those cave formations are called speleologists.
Speleologists. That's cool.
Yes, and it's really cool because they can also study those drips and those cave formations to find out what it was like here a long time ago. So they can tell what the climate was like 10,000 years ago by studying those cave formations. So that's pretty cool. Excellent question. They take a long time to grow, and we don't want to touch them with our hands if you're ever in a cave, because the oil from our hands can make it so they can't form anymore.
Wow.
And you don't want to break them because they're fragile. So.
Do you have one last question?
What neighborhood is the Millennium Cave in?
So Millennium Cave is at Village of Western Oaks neighborhood, and it's called Village of Western Oaks Karst Preserve or Karst Management Area. Watershed, sorry, we changed the name recently. I think it's Karst Preserve and Watershed Management Area. So Village of Western Oaks, and once again, that cave is gated, so you can't, it's not currently open to the public, but you can go check out the park, and there are at least 5 caves in this little park, and it's right off of Davis Lane, just a little to the west of Mopac. It's near Escarpment and Davis Lane.
Do you know any caves that you can go in?
Yes, I do. So except for some of them, it's kind of tricky right now with COVID. But some organizations you can check out to get into some wild caves. Well, first, there are commercial caves like Inner Space Caverns. It's just a little north of Austin near Georgetown. Have you been in that cave?
No, we haven't really been in any caves.
Okay.
We've been in one cave.
In Arkansas.
Oh, yeah.
Oh, cool. So there's another cave that I take students a lot into called Whirlpool Cave. And it's also in Southwest Austin, and it's owned by the Texas Cave Management Association. And so if you look up TCMA, you can find out about their caves. They own a lot of caves in the Austin area. And there's an organization called the Underground Texas Grotto, or you can Google UT Grotto, and they have meetings every other Wednesday. And then they also, when it's not the time of COVID, they do tours. So there's ways that you can go check out a cave, and they can help you if you need some cave gear, and you can go check out some wild caves in Austin. And then, yeah, when you're in middle school, that's what I take some middle school students caving. And so you might be able to do that. But yeah, I recommend go explore.
Have you ever seen any really cool stuff in caves? Like
I have. I love cave critters. So one of my favorite cave critters that I get to see in caves, it's called the slimy salamander. And one student described it as looking like the night sky because it's really dark and shiny and it has white spectacles on it.
Is it
So
slimy?
it is slimy. It is so super slimy. That's why it's so shiny too. It's different than the Barton Springs or Austin blind salamander because those salamanders only live in the water. And this salamander lives on the land, but it likes moist areas. So that's why it likes caves. And we have a lot of cave scorpions and spiders and harvestmen and cliff chirping frog and Gulf Coast toad and lots of snakes that we've seen in caves. So, and one student in one cave we go into even found a fossilized bear tooth. So do we have bears here in Austin? Not now, but so this one was from probably about 50,000 years ago. Bear tooth.
I'm so surprised.
Yeah, but there are lots of cool cave critters, and a lot of them have special adaptations. So another favorite cave critter I want to tell you about is called the cave cricket. And they have do you know about them?
Oh, they're red and they can swim.
And the cave crickets that are in our caves, they have really long antennae and really long legs. They look different than surface crickets. And so they can sense their surrounding environment. But they leave the cave at night and they go eat on surrounding vegetation and other things at the surface. And then they bring all of that food energy back into the cave. And so that provides food resources for other cave critters that can't leave the cave. So they're called a keystone species because they're so important for the survival of all the other cave critters. You like cave critters, I can tell. Y'all have excellent questions, and I'm so excited that you want to go caving and that you want to start a rain garden. And my contact information is included on the page too. If you have additional questions, you can contact me. So.
Thank you. Thank you very much. And I guess for now, we'll have to say thank you, Jessica, and thank you so much for joining and sharing this great information on how we can protect caves, surface water, groundwater, and I hope the students explore. For those of you watching on YouTube, if you have a question that we didn't answer, leave a comment below and we'll do our best to get an answer to you. Also, check the description for links, video links, and more information on our website. And don't miss our next talk with Natalie Ballou of the Texas Water Development Board on the secret life of groundwater. That'll be live today at 2 p.m. Central Standard Time and soon thereafter on YouTube. Thanks for watching. See you next time. Bye. Thank you.